Hello, everybody. Good to see you this morning, although I don't really see any, well, I do see some names. I'm really pleased to introduce Mike Beck. He's a research professor in the Institute of Marine Sciences, and he holds an adjunct professor position in ocean sciences. One of the reasons I invited Mike is as part of the Institute of Marine Sciences, I'm trying to get our researchers to give a seminar at least once a quarter in an appropriate department. And so Mike's going to be our first lead off in the EEB program. Last quarter, I had Megan Cimeno give a lead off in ocean sciences. Mike is also recently a recipient of the AXA, or the AXA Chair in Coastal Resilience. It's quite a big award. I think it's a 5-year program. Mike got his BA and MS from University of Virginia, a PhD from Florida State University. And from there, from the East Coast, he went and did a postdoctoral work in Australia. And I always like when I hear people having done something in Australia. I've done a lot of work there. It's a great place. Mike's been part of the campus and part of the Institute of Marine Sciences since 2000. He was from 1998 to 2008. And during that period of time while he was here, he was a lead marine scientist at the Nature Conservancy. And so he was a major player in the Nature Conservancy and working with us to establish a good relationship here at UC Santa Cruz with the TNC. He's been a Fulbright Fellow and he's a Pew Marine Conservation Fellow. And he's quite a collaborator. He works regularly in the interface between science and policy. He works with conservation NGOs, insurance companies, the World Bank, government agencies from many nations. He's worked with government agencies in the US, Germany, UK, European Union, the Philippines, Jamaica, Grenada, and many others. And he's also worked with a lot of insurance companies because he's working on this interface between coastal resilience in terms of sea level change and advising what the future brings. So with that, I'm really pleased to introduce and hand the podium over to Mike Beck. Mike.
All right, thanks, Dan. Really appreciate the intro, and I've really appreciated all the collaboration with folks here over the 20 years, and for folks like Gary Griggs and Mark Mangle and Don Kroll for helping make it possible for me to be on campus, and now more fully while I also continue to collaborate with the Nature Conservancy. Okay, so let's talk disasters, because we have no idea what those are like. All right, as we know, the cost of natural disasters are rising rapidly on our coast. This is mostly from population growth and poor development choices, but increasingly we're seeing signatures from climate change. And these are putting both people and nature at great risk. The response to natural disasters is already taking up more and more of our national budgets. And this was at a time when environmental funding was already under strain. Unfortunately, at present, as I'll show you, very little disaster money goes to the environment. In fact, it often goes to more gray solutions, which is even more destructive to the natural environment. But if we can show that nature can be effective for building resilience on our coasts, then it has the potential to open up vast new sources of funding for conservation and restoration. So in this talk, I hope to convince you that we can, in fact, rigorously quantify the flood protection benefits from habitats, and this creates innovative financing opportunities. And my hopeful message is that with a little bit of disaster jujitsu, that we can help nature help us. Okay. All right, first off, I want to make sure to recognize just a handful of our many collaborators. The extended lab group is on the right of your screen, includes a number of key research staff like Borja and Pelayo, and quite a number of students who are involved in the work, some in our lab and some working with us from other labs, and some recent past collaborators or continuing collaborators who have new positions, professorship positions on the East Coast in Sid and Nadine. I also want to acknowledge, and it's a very important part of our collaborations enabled through the Institute of Marine Sciences, is our work with USGS collaborators, particularly Kurt Storlazzi and Kristen Cumming. That partnership has been incredibly important, particularly in recent years. We have on the left a number of really close collaborators. Sometimes they're funders, but we're working on projects together, and they cover government agencies, engineering institutions, NGOs, insurance companies, and the World Bank. And you're going to see me talk about those pretty regularly in the talk here. Okay, before I go too far here, I'm going to be talking a lot about money. I'm going to be talking a lot about values and finance. And you kind of somehow think that all I care about is how much dollars environment's worth. And I want to dispel that notion right from the start here. I believe in nature for its intrinsic value. I hope we conserve more nature for its intrinsic value. This here is my favorite spot on Earth, in Eleuthera, in the Bahamas. And by most of the measures that I'm going to show you throughout the rest of the talk, there's almost no value here because this has very little people or property in the approaches that I'm going to be describing. But it's really important. So I care about those, but then we also really need to figure out how to bring other champions, and particularly in this age when risks are increasing, how we can have the environment a real part of our solutions for building coastal resilience. Okay, why are we talking about coastal resilience? Well, and coastal protection services. Again, these risks are rising. On the right is Hurricane Irene. It's just about to pass over the spot that I was just showing you in the last photo in the Bahamas. On the left was an image of Hurricane Michael, Category 5, which really devastated the panhandle there, northern Florida. In Wonder Chat, Ingrid and I were just reminiscing about the times that we spent together at our field house there in St. Joe Bay. That area got incredibly decimated. Ingrid, I counted, it was more than 9,000 moons ago that we spent time there. Okay, and risks are rising. These are some data from Munich Re looking at essentially the costs, the continuing costs of natural disasters, and these are just going up. And that's payouts from both public and private insurers and recovery agencies. A couple of years back with Erin McCrellis, she was a grad student and then a postdoc here in the department, we took a look at where we've been spending on building resilience on our coastlines. And we took a look at funding over a 10-year period, looking at that went into, like, let's call it green or natural infrastructure, this kind of conservation spending, and the rest, which was going into much more artificial solutions. Basically, over that 10-year period, a few billions of dollars were going into conservation, whereas hundreds of billions of dollars were going into things like recovery and insurance payouts. And again, most of those end up in gray solutions. In the conservation community, we talk all the time about, wouldn't it be amazing if we could double these budgets for conservation? And we should, and that would be amazing. But what if we could do a bit of that jujitsu and have more of these payouts go to supporting nature and the natural environment? And so that's a lot about what we try to do in the work that I'm going to show you. This is just another example of how that spending has happened. This is the spending from Hurricane Sandy, where we're looking at essentially only about 1% of that spending that went into green or natural infrastructure, and the rest into much more gray infrastructure. And this is the story, kind of storm after storm, as it were. Okay, so if we're going to be able to access some of this funding for nature, then we've got to be able to calculate the benefits in ways and measures appropriate for the insurance, engineering, disaster recovery businesses and agencies. And in 2015, in a workshop here in the Seymour Center, remember workshops, we convened a group of about 40 experts with the World Bank to come up with an approach for valuing coastal protection benefits. And I've summarized a very complex set of approaches, a set of models and data in this sort of 5-step program. And this is going to be central to all of the results that I show you. So very important. I'll go over it. What we try to do first is estimate waves and the wave environment, storms offshore. We follow that water and those changes in water heights as they get near shore, and a new set of processes and models describe how that water and that flood water changes as it gets near the coast. We then take a look at how habitat modifies waves and storm surge. And then we follow the water as it comes onto land, begins to flood, and we look across the entire storm frequency distribution from your 1 in 10 year to your 1 in 100 year storm, and the damages with and without habitats. So I've shown you a line here. This is an imaginary line, the solid pinkish rosius line, which represents flooding from a 1 in 10 year event as it is now, that is with habitats in place. And then we remove some portion of the habitat and we ask, what does that new flooding look like? And so more areas get flooded. And then we assess the people and property between those two flood lines. These are the people and property benefiting from keeping those habitats in place. So this is core and central to everything that we do in these models. I'm going to show you a little bit of a visualization that the California Academy of Sciences developed. It had been visible in their planetarium show. It's a little 1-minute video, shows storms coming across into Mexico, an area that's going to feature later in the talk. And you'll see actual results from our wave models being generated here.
Here we see the Mesoamerican Barrier Reef, the largest coral reef in the Atlantic Ocean. When Hurricane Dean struck Mexico's Yucatan Peninsula in 2007, the reef helped shield the shoreline. Scientists created a computer simulation to understand how this works. Reefs dissipate waves' energy, reducing wave height and slowing the water before it crashes into the shore.
Okay, so that kind of gives you some idea of the sort of offshore and nearshore modeling that we're doing, a bit of a visualization about that. So now let's talk coral reefs and the value of coral reefs, and then I'll get into mangrove habitats. A lot of this work started for us back in 2014 with an Italian grad student who was based here, Filippo Ferrario, and we were trying to do meta-analyses to understand just how important reefs were in breaking waves. And I quickly realized, was out of our element in understanding some of the wave energy calculations, and quickly partnered up with Kurt at USGS, and we've had a very fruitful collaboration since then. Reefs work to reduce flooding by breaking waves. So that's the principal thing that they're doing in terms of wave energy reduction. And in our meta-analyses, we showed that reefs reduce 97% of the wave energy that would otherwise hit coastlines. In our analyses, to understand the value of habitats, we have to do comparisons with, that is, existing conditions of reefs, and then without reefs. And whenever I talk about without reefs, I'm not talking about the disappearance of reefs entirely. I'm just talking about a loss of 1 meter of the topmost portions of the reefs. And that is the sorts of things that we are seeing, the sorts of losses that we are seeing globally due to climate change and other coastal development impacts. Everything that I talk about in these global models is ultimately predicated on assessing flooding very locally. So for this coral reef work, we assessed essentially flooding across all 70,000 kilometers of coastline around the world with coral reefs. And at 2-kilometer intervals, we assess flooding onshore in scenarios with reefs. So that's this kind of tannish layer. And then without reefs, for a variety of different storm events, so that we can compare that flooding and then the people and property underneath these areas that would be flooded without those reefs. You can go to this TNC decision support system, and you can see a variety of the kinds of models and results that we've generated in looking at flooding across the storm frequency distribution. And again, this work we do across more than 60 countries to be able to come up with these broad global estimates of the value of reefs. And this is one of the core results from our 2018 paper, where we're again looking at the built capital flooded across storm return periods from your 1 in 10 to your 1 in 100 year event with reefs, and then the additional flooding of built capital that would happen without, if you lost just the topmost meter of your reefs. And the short message here is that overall, if we lose just the topmost meter, the costs of storms would double. Reefs are really important in reducing flooding. And because of the way that we approach these analyses with very high spatial resolution, we're able to identify where there are hotspots around the world where reefs are providing the most significant values. And so that can be, we're looking here at the annual expected benefits from reefs. So that's the avoided flood damage in millions in these coastal study units for us, 20-kilometer coastal study units. And you can see that there are many areas where reefs are reducing more than $50 million per 20 kilometers of coastline in damages every year. And we can also sum those up by country so that we can understand the countries where reefs are providing the most significant benefits. And this is also ultimately important for our work with the World Bank, which really does try to assess the values and benefits of these, who together we're trying to assess the value, the benefits of these habitats in ways that could get incorporated into each country's gross domestic product. And that's important because otherwise the gross domestic product only accounts for what we take from nature, not the values and benefits of leaving nature behind. And you can see that for some countries, like these top 5 here, reefs are providing more than $400 million in flood protection benefits and direct flood protection benefits alone. So really important, really valuable. We can put numbers on it, kinds of numbers that could get included into national economics. In this coral reef work, we're now going to much higher resolution modeling that's possible when you have much better data sets on topography, bathymetry, reefs, and assets. And so that's work that we're doing with USGS. This is from a report released year before last. Again, completely predicated on being able to assess flooding at very high resolution. Here, image from Miami, where we're looking at flooding in a 1 in 100 year event with reefs at present, and then the additional flooding, and you can begin to see properties resolved underneath this, the areas that would be flooded if you lost that topmost meter of reef. And we did this very high resolution modeling across the entire, all reefs in the US, all states, all territories, and overall in both direct and indirect benefits, reefs are reducing flood damages by US reefs by $1.8 billion annually. And again, we can identify the hot spots where those benefits are really important, and that guides a lot of where we can invest in reef solutions for reducing these flood risks. We're just in the middle or not in the middle, we're at the very end of a set of projects that arose after the 2017 hurricane season. Together, USGS and UCSC received some supplemental funding to understand both the changes in flood risk due to damages that affected the reefs in one series of reports, and then in another series of reports, what's the potential value in restoring reefs? So what I'm showing you here is an image near San Juan, Puerto Rico, some areas where we're looking at potential for reef restoration in these lines here offshore. And we're looking at the 1 in 100 year flooding that would occur with reefs at present. That's the red areas here. And then we took a look at a variety of restoration scenarios. And I'm not going to go through the different restoration scenarios, but they're a mix of biological and structural restoration, and asked how much less flooding there would be, and then valued the benefits provided by that restoration. And this is really critical because to access some of the money, a lot of which went to FEMA from recovery, and there was $100 billion allocated appropriated by Congress after the 2017 hurricanes. If you want to be able to access some of that funding to restore reefs as natural infrastructure, you have to be able to do this kind of calculation where you're really assessing, if we put this solution in this spot, how much flood reduction benefits specifically would there be? And so this is work that's going to come out later in the spring here. And working with Jessie Kendall Barr, you'll probably have seen and noted that she's helped with quite a few images and communication products associated with this work. We summarized some of the coral reef work here in this graphic. Actually, what I really wanted to know was down here at the bottom, which was why when wave height went up just a little bit, I felt like I was getting throttled so badly in the surf. Well, yes, as we know, wave power increases exponentially with wave height. But okay, so really in terms of the summary, what we're finding is that just a loss in a meter of reef height increases the wave power, wave energy that's passing over reefs and onto shore by some 4 times, and that creates a doubling in flood damages. And so that's a summary from a huge amount of work over the past 6 or 7 years. Okay, let me turn now to mangroves. And again, we're using the same sort of approach where we're using the 5-step model. We're examining waves as they come from offshore, onshore, and looking at the additional flooding that happens without, if you were to lose in this case, all of those mangrove habitats. This is a nice little flume video that helps to describe for some folks how mangroves work at reducing, in this case, waves, but they work in a very similar way on storm surge, basically acting to block storm surge and dampen waves, and then show up at the back end here with very still water and little flooding onto shore. I've worked in a variety of countries, and in the Philippines, where we've done a lot of work, and I'm going to show you some results. We went through all of these modeling results, very high resolution assessments of flooding and risk, and it showed those to the Vice Minister of the Environment, walked through all the results, tried to make it made it very clear, I hope. But then we showed this video and she said, oh, show that again, show that again. Oh, I can take this to the minister. And so in some ways, a visual representation for some decision makers is really important. Again, I want to emphasize, I'm going to be talking about global flooding numbers. So it seems like they're just all big, broad, but they're all based on very high resolution assessments of flooding onshore. This is just an example from Grand Bahama Island. Some of you may remember this is one of the places devastated by Hurricane Dorian a couple of years back. This is showing the 1 in 10 year flooding event with mangroves in blue, and how much worse just this somewhat regular type of flooding would be without mangroves on a very low-lying place like Grand Bahama Island. And you can see that mangroves are preventing and have been preventing quite a bit of flooding there. Okay, so for the mangrove work, we first developed this model in the Philippines, and we then asked, just as I was showing for the coral reefs, what was the benefits of keeping those mangroves in place? What would flooding look like in terms of people and property affected with mangroves at present and blue, and then without mangroves in red. And we can look at the differences in people flooded, vulnerable people flooded, property, and public infrastructure. And in all of these cases, we're seeing somewhere around a 25% increase in damages. So throughout the Philippines, these mangroves are providing really important flood reduction benefits. And again, importantly, because of the high resolution analyses, we can identify where, and that's very important for decision makers. But it's also not surprising to know that the value and benefits and where those values and benefits are greatest really varies depending upon what's the metric, what's the asset you're measuring. So on the right is the, one second, let me move that out of the way. On the right is where we identify where mangroves are providing the greatest flood reduction benefits to property throughout the Philippines. And you can see that that's very important, for example, not surprisingly, around Manila and around some of these bigger cities and municipalities in the southern portions of the country. But when you look at where mangroves are important for protecting particularly vulnerable people, you see that those are really concentrated here on the eastern, the outer eastern edges of the Philippines. And this is where some of the very worst of the storm impacts are felt as they come across. So again, very important to recognize that we need to be thinking about both people, and particularly vulnerable people, and property. And this work on social vulnerability and valuing the benefits of habitats for reducing social vulnerability is something that we're investing a lot more in our group here. Okay, just like for the coral reefs, we also last year published a map paper on where mangroves are providing the greatest flood reduction benefits globally. And the mangrove coastlines that we assessed were across more than 700,000 kilometers or hectares rather of mangroves across more than 75 countries. And you can see that there are places where mangroves are providing really important annual flood reduction benefits, very significant. Okay, so I've showed you work on reefs and mangroves so far, flood models that we developed, but we developed in ways and approaches very similar to those used by the industry. But then we also got some support from Lloyd's of London to work directly with the industry using their risk models, and risk management solutions, or RMS here, is one of the leading firms assessing risks for the insurance industry and for many investors. And so it's very important to be able to ask, what do their models say about the role of habitats in risk reduction? And it was actually at a workshop here in Santa Cruz back in probably about 2015 that I asked some of the RMS modelers about that. And their answer at the time was, huh, we're not sure. No client has ever asked us that question before. And so together we went in and we examined what was the role of marshes on the East Coast of the US, particularly during Hurricane Sandy, in providing flood reduction benefits. And in their model, we find that the reduction in damages during Sandy was over $625 million. We also looked across a variety of storms, and over here you see the difference in losses in Sandy, and the areas, the redder areas, are where these marshes are providing even more significant, the most significant flood reduction benefits. We also looked across a variety of storms and found that on average, there's a 15% reduction in flood damages from marshes. And importantly, this is at the level at which you could expect premium incentives, that is reductions in the costs of policies by keeping marshes on your property. So that's really significant. And this has actually begun to take some hold in the industry. We've been approached by some other insurers recently, and they said, hey, you ought to go talk to RMS. They're actually incorporating some of the habitats in their models. And I said, yeah, we know. My colleagues at RMS and I, we had a good little chuckle about that. We've also been working with the industry to then take some of these benefit values for mangroves, put them together with the costs of projects to be able to identify where you're likely to get high returns on investment or benefit cost ratios greater than 1 for mangrove restoration. And you can see that there's many opportunities. I mean, essentially all of these colors from the yellow through green are areas that are likely to yield strong returns on investment for mangrove restoration. So this is actually also something that we're working closely with the industry on to understand where we might be able to implement and pay for some of these solutions. All right, one of the other things that I want to point to just quickly that we're right in the middle of finishing up, and it will be released later this spring, is work with the World Bank on the changing wealth of nations. And what we've been working to do is to be able to put the value of mangroves by country into this report and the World Bank databases so that they can be used globally. And I think probably the most important, I'm going to show you some of the results, but I think the most important quote here is that the asset value of mangroves is explicitly included in the World Bank's core wealth accounts for the first time in this edition. And so we're achieving kind of an important goal for our work overall. And this was made possible. It's possible for us to examine the role of mangroves over time because there's been new databases released on the distribution of mangroves, the global distribution in several new time periods. So there's maps now for mangroves in 1996, 2010, 2015. These are the ones that we examined, but also a few other time periods as well. And what you see, not surprisingly, particularly for that period in the early 2000s, that there's been a huge global loss of mangroves, 4% overall globally. That slowed from 2010 to 2015, but was still a global loss overall, even though we've highlighted here a few countries where there were some significant increases in mangroves in that time period. But we first took a look across that time period at flood risk. And overall, and not surprisingly, flood risk on mangrove coastlines is increasing greatly. This has a lot to do, mainly to do some with population growth, but just increases in wealth, that is GDP overall on our coastlines. We looked at then mangrove benefits, and mangrove benefits are increasing over this time. So even though we're losing mangroves, fortunately at a somewhat slower rate now, the benefits, just because of how quickly risk is rising, the benefits of those mangroves are going up. And you can see that particularly displayed here if you look at mangrove benefits per hectare. So with fewer remaining mangroves, they're even more valuable. Again, this has more to do with increases in wealth in our coastline than loss of mangroves, but still kind of important. Okay. So that describes a lot of the kinds of results, the work that we've been doing to really value the benefits of these habitats. What I'm going to now talk about in the remainder of the talk is a few examples of how this work is getting applied, and also importantly, as represented in this graphic here, what the focus of our lab and group is going to be over the next 5 years or so as part of this AXA chair in resilience. And so what we're trying to do is take these key results, use them with these stakeholders, make sure that nature is included in industry risk models so that it can be incorporated by underwriters, make sure that, I don't know if that's blinking out on your end. I'm gonna just proceed here, go back. Sorry?
It's working.
Oh, was it? It was really blinking on mine. Let me start it one more time.
But
Thank you.
blinks in, but it is working.
Okay.
Yeah, it works fine.
Okay, yeah, sometimes the second time works a little better. So we get nature incorporated in risk industry models, nature incorporated in national economics like GDP, nature incorporated into benefit cost analyses like those used by FEMA so that we can access recovery funding, and to develop innovative new investments so that we can help to restore and conserve nature for its risk reduction benefits. And as I've said all along, all of the kinds of partners that we work with are incredibly important for helping to realize these kinds of opportunities. So again, working very closely across the spectrum here. Okay, I've shown you a lot of model results so far. I do want to note that some of this work that we're doing directly in the field, helping to build reefs, whether it's oyster reefs in Alabama, coral reefs in Grenada. For the oyster reefs work, we're now doing miles of oyster restoration projects across the Gulf of Mexico. A lot of that supported by a different kind of disaster funding from the oil spill in this case. But we've also been developing some of these new approaches for investing and ensuring the flood reduction value of habitats. And the first in the world policy for a habitat was done for the coral reefs. We did with partners for coral reef in Mexico near Cancun, where they recognized the value of the Mesoamerican reef for reducing flooding to the tourism infrastructure. And that's not just the hotels themselves, the buildings, also the jobs that those create for local people. And we put an insurance policy on the reef so that if there was a storm that damaged the reefs, there would be money to recover that reef. And a New York Times article just a couple of months back describes the first payout from that policy. So as you know, this was a very intense hurricane season. Hurricane Delta affected this area pretty badly and was just enough to trigger the insurance policy on these reefs, which then triggered an immediate payout, which supported local fishers and others to get out and help put repairs onto those reefs, collect damaged corals, and set up restoration programs there. I can tell a different time we will talk story about the days after that event and calculating just whether or not this policy was triggered because it was right on the line. But I can also tell you that the triggering of this policy has then generated enormous interest in quite a few places. The work that we did with partners and led by the Nature Conservancy has also been influential here in California, where Ricardo Lara, when he was a senator, helped support and pass this bill, State Bill 30 on insurance and climate change, where the state is actively looking at opportunities to employ kinds of mechanisms like we did in Mexico for reducing risks of climate change. And if you now hear him speak, and he's now the insurance commissioner for the state, he talks all the time about the kinds of values that we've been generating from our research. He doesn't necessarily know it's us who's generating those values, but they're there when he talks. We have also been working to develop some really innovative products following on from that Mexico insurance, and we're working with Munich Re, they're the world's largest insurer, on a kind of resilience insurance. So instead of just paying out for damages after a storm event, we're looking at ways to invest in risk reduction measures ahead of time that can get paid for by premium reductions over the course of that policy. We published some of this work last year, and we're working together with a resort in the Dominican Republic and Munich Re and the Conservancy to figure out if we can implement such a policy. I can say it's complicated, but we hope to be able to figure it out later this year. Something else that we've just done and is available, we've developed a standard accounting approach for assessing and getting credits for coastal resilience benefits. And this just went out for public review by Vera. What you can think of this like is the blue carbon accounting standards. So if you want to have private or public investors invest in habitat restoration, for example, for carbon credits, there has to be a verifiable accounting scheme addressed by a third party like Vera. And we've developed one so that not just for blue carbon, but you could get credits and investors can buy into and get credits in the future for the flood reduction benefits provided by these habitats. We're also looking at the kinds of incentives that would inspire local homeowners to build more natural solutions. And so we asked Alabama coastal landowners if their bulkheads which are very commonly used on the coastline, were damaged by storms, would they be likely to put in a more natural infrastructure? And at first the answer was unlikely to change, not surprisingly. But when we said that there could be some cost share related to that, then there was a much significant increase in the likelihood that they might consider some of these natural solutions. And quite importantly, the scale of that incentive does not have to be huge. So we asked, how much cost share would convince you? And the real answer out of this from them was that it wasn't so much that it had to pay for it in total or even had to be that much of the total cost. It was just the signal that was being sent that there would be an incentive for building natural solutions. So this is something that we're working to explore further. FEMA is now making it easier to include nature-based solutions into risk mitigation projects. And this opens up a great possibility for getting both pre-disaster hazard mitigation or post-disaster recovery funding directed towards habitats. The Army Corps of Engineers is also taking a leadership role in natural and nature-based solutions. This was the gang from a workshop held here by the Army Corps' Engineering with Nature program. The ultimate product of this work is out in the spring. We're a co-editor on that. International guidelines on natural and nature-based features for flood risk management. This is going to be a huge and authoritative tome on this work and very important for future work in nature-based solutions. And then just right around the holiday time, the Department of Defense DARPA program launched a new program called Refence, where they're going to support innovations in the development of oyster reefs and coral reefs for coastal defense, particularly around coastal military installations. So they've just established a $40 million innovation fund. The work that we've done together with USGS has been very instrumental in helping to make the case for these kinds of opportunities. And we're likely to see a huge amount of real innovation in the coming years around these natural defenses. Okay, so what I hope to have convinced you of is that habitats do reduce flooding and erosion. We can really rigorously value those benefits. This supports innovative funding for conservation and allows the potential, and we are seeing the redirection of funds for hazard mitigation, disaster recovery, and climate adaptation from gray to green solutions. So to answer the question that I tried to raise at the beginning, can disasters save habitats? I think the answer is yes. And in fact, I think they have to, because otherwise our investments, which are growing in recovery, are otherwise going to damage these habitats. So in our lab, what we're trying to do is to build coastal resilience naturally to protect people, property, and nature. And I want to thank the many funders who have helped support this work. Thanks, everyone.
Well, that was excellent, Mike. Really important work and really exciting to see this work and that UCSC is helping to lead the charge. Any questions out there?
Dan, do you want us to raise hands or anything? Or
I'll just speak up for now. Let's see how it goes.
Okay. Hey, Mike, one question. Well, three. When you were describing the coral reefs, you were using a 1 in 100-year storm event. And when you went to mangroves, you went to a 1 in 10-year storm event. So my first question is, are those frequencies sort of industry standards that you have to use, or did you come up with those frequencies? The second is, how do they resonate with the agencies or policymakers that you're presenting this to? And then the third is, what's the sensitivity, the economic benefits to changes in those frequencies? So like the 1 in 100, what's it like for 1 in 50 or 1 in 150? How does that affect the values?
Yep. Well, okay. So first off, I was just showing you some example results from the different habitats. So in order to come up with an annual expected benefit, which is one of the core metrics, you have to be able to do that across the storm frequency. So for both coral reefs and mangroves, we're doing that flood mapping for the 1 in 10, 1 in 25, 1 in 50, 1 in 100. So that's done for each of those habitats. There isn't truly one standard of frequencies that you need to look at, but we are following frequencies that are typically used in assessments. Let me answer your last question before getting to the middle one about how it's used. We do find that habitats have an even greater percent benefit for some of your more frequent, somewhat less intense storms, so that, when you're really reaching those Category 5 events, reefs, for example, are still providing real values and benefits, but on a percent basis, a bit less, because at some point, the waves, the surge just get too high for these benefits kind of overall. And then there's a whole nother area of work that I haven't discussed, which is the fragility, which we also have been calculating with the industry, which is, when do these fail as defenses? So when could storms rip out mangroves and marshes, creating the potential for even worse damage? And when do the reef defenses fail, which is also important for the restoration. The acceptance and use of these kinds of values has been very high by managers, and I mean that at kind of all levels of government, and we're seeing them used by the IPCC and others. The industry, they've been using them in a variety of ways, but each of these partners wants to use our results slightly differently. So it'll be a longer story, which I can tell you later, about how we essentially modify the core results. And give you different measures or parameters relevant to the industries and decision makers, which are different depending upon who we're talking to.
Laura, you've unmuted, and then Jan, I guess you guys want to ask questions. Laura,
Yeah.
go ahead, Laurel.
So I have a question that takes you out of the kind of habitat you're comfortable in. And that's about, have you thought about this for terrestrial systems where people are more integrated into the habitat? They live within the habitats. And so one of the mitigation measures, for instance, for fire reduction in the Santa Cruz Mountains and many other places, is to cut down habitat so that you don't have trees and native trees and shrubs growing near your house. It's reducing habitat. So it's a very different kind of situation. I was wondering whether you've thought about how your approach might be used in those kinds of situations.
Yes, so I have been thinking a bit more about that. It's kind of funny that I'm now much freer to explore those solutions, because for 20 years with my TNC marine program hat on, if I said, oh yeah, I want to explore forest fire, oh my goodness, there was no way I was going to be allowed easily to do that. I'm now much freer to do that, and I have been looking at some of the forest resilience bonds that have been used up in the Yuba watershed, if I remember correctly. A lot of the structure of how they're developing these resilience bonds, we're learning something about for the work that we do coastally. I have a lot to learn or relearn about terrestrial environments and fire, for that matter. But our program is kind of open to exploring those more.
Okay, Jan.
Yeah, this is also maybe a little outside of your
usual territory, but I'm wondering about riprap. I mean, this is a huge problem all over California. Is people want to protect these eroding cliffs with riprap and so forth and so on, and whether you've looked at alternatives to riprap or the effect of riprap on damage to coastal bluffs with rising seas and possibly more intense storms.
Yep. Yeah. A great question. I'm going to move from riprap in California to riprap in, say, Hawaii or island nations with coral reefs for a minute, because this is actually really important and an area that we're going to be expanding work into. So what we're trying to convince folks is that they should invest more in protecting that first line of defense so they can reduce the amount of riprap that they're otherwise using to protect quite often roads. So if you think about islands, island nations, our states, those ring roads around the coast are the lifeblood for those. And they're protecting them all the time with riprap, and increasing in many of these nations because they're allowing their reefs to die, and they don't recognize the connection that that's part of why wave energy and erosion is increasing in these coastlines. We're also trying to highlight the fact that some of this is Borja's work on global wave energy, that we often think about climate change in terms of sea level rise. But for coastal infrastructure, like roads, like riprap, wave energy is also increasing. And from an engineering standpoint, from a structure standpoint, a longevity of our structure standpoint, those increases in wave energy are likely to have much more disastrous effects than even sea level rise.
So, Mike, I'm curious in terms of, what about kelp forests? Do they have, I mean, it seemed that they would also have an energy absorbing role as well.
Yeah, some, but much less. And you know, I tell this kind of story as a surfer. I mean, you know, the reason we're surfing behind kelp forests is because kelp forests aren't doing a lot to reduce the overall size of the wave. They're just taking the ripple off of the top of it. Is the kind of main effect. That's obviously not engineering speak, but you know, overall, because it's a flexible plant, they're impeding not that much wave energy. So some effect on erosion, but small.
Anybody else out there?
I have more of a general question. I just find it really fascinating that you cross so many disciplines like academia and finances and nonprofits, right? I'm just kind of wondering, like, as an emerging scientist, like how you get involved in so many disciplines like that.
Yeah, well, some of the things just compounded, as it were. If you had told me 7 or 8 years, so I'm an ecologist by training, and really a field ecologist. I did lots of relatively small scale experiments until I joined the Nature Conservancy. I was working, you know, at the University of Sydney on little rocky plates in the intertidal. I got to the Nature Conservancy and they said, "Hey, could you develop a plan for us for, you know, just like the whole Gulf of Mexico?" So, you know, kind of very quickly learned that I was going to have to think at different scales. And if you want to work in an NGO, you have to like solving problems, because you're never going to solve the same problem twice, it seems. You know, it's always a new thing. It's always a hot topic. It always needs to be addressed really soon. So you just have to like problem solving. And I found that I like problem solving, and I still like to learn new things. And so if you told me that we'd mostly be working with engineers and insurers starting 5 or 6 years ago, I would say you're crazy. But it's been very interesting, and they really do want to try to help in many cases. And so it's been very interesting looking for those collaborations.
That's a great question. I remember, Mike, when you first came, you really were a marine ecologist, and I've watched over the years how you've transitioned and sort of thought that same question. It's quite great question, great answer. Anybody else out there?
Hey, Mike, I had a question.
Go.
This is a Patrick Barnard, USGS. That was just tremendous body of work you summarized, Mike. Thanks so much. It reminds me I need to circle back with you on a few things. One question I had for you is on the financial side, and sort of what's your view of the role of like bond rating agencies like Standard & Poor's and Moody's and how they value like municipal bonds in relation to climate change and climate adaptation. Just wondered if you could speak generally about that. That's a topic I'm starting to try to learn more about and kind of where the rubber meets the road in some cases.
Yeah, so a very good, very important topic. I think that there may be even more opportunity for growth there in support of these natural solutions than at least with hazard mitigation funding, and maybe even more than recovery funding. And this, in terms of the upcoming strategies that we're working on, working with folks like Risk Management Solutions, RMS, to get nature incorporated into their industry models is really important. And I showed you how they incorporated into, what we might call their full-scale model. But what's really important is to get it incorporated into their underwriting model. And getting it incorporated into their underwriting model takes many steps and is not a simple thing to do. But ultimately, that informs not just the kinds of insurance incentives, your premium incentives that you might think about, but exactly what you're talking about, Patrick, which is whether or not you can get essentially approval for investors to help fund bonds that would support natural solutions. Because somebody like RMS has to say, oh yeah, we identify that those kinds of solutions would work to reduce those risks, and you do have a way to pay back that bond.
Thanks, Mike.
And I'm sure Patrick and I are collaborating on a variety of things. I didn't get to talk about some of the San Francisco Bay work that we're doing together. And I'm sure when he said, "Hey, I want to double back with you," he's like, "I got to correct a few things he said." So I'll expect a call from Patrick.
No, just a really interesting topic, and not something that we learned about in grad school. So I'm trying to keep educating ourselves on how we can support this kind of work. And ultimately, a lot of ways, I think, Wall Street is going to control the amount of funds these communities have to respond to some of these events and long-term impacts.
Yeah, Wall Street and governments, and if we can essentially leverage one off the other, then again, we can unlock a lot of support here.
Excellent.
So any other comments, questions? Mike,
I have a quick comment. Mike, because we're out of time, I'm going to ask you a question that requires an entirely separate talk probably. But I know that you and the team have been working extensively on equity issues, right? Incorporating equity into these evaluations and trying to provide equity-based recommendations. And so I'm just saying this because I think there would be really strong interest in the grad students and faculty to learn about how you approach and navigate that. And so maybe sometime in the future, we could do a separate, even if it's a Friday group or something, where you can really dig into how you're trying to incorporate equity into this process.
Well, it'd be really nice to just have that discussion, because we are doing some things. We want to be doing more things. I've got some proposal feelers out there for that. But this is an area where there's opportunity for collaboration with folks here. Absolutely.
Cool. So that we're at the time limit for our formal seminar, but we now can move into the just open discussion and Q&A. So I'll just end the formal thing, but leave Mike here and say, Mike, thank you. It was a great seminar. It really opens up our eyes to see what this guy that's been sitting there in Ocean Health Building has been doing. So I really appreciate you taking the time and giving an excellent talk. So again, we'll now just move to an informal interaction. So anybody that wants to stay and chat with Mike is welcome to do so.